Hello, and welcome to the fourth video of Sum Integrals Preliminary Calculus Information. This video will be on sets. Sets are a really important topic in mathematics. They're kind of the building blocks for how we talk about numbers. If you ever study a more rigorous math class, you'll probably construct numbers based on sets. But for now, let's just talk about the basics of sets. So we'll start off with the definition. What is a set? A set is a collection of objects. And that's really it. That's all a set is. It's just some assortment of things. So these objects could be anything. They could be the letters of the alphabet. They could be all the numbers. They could be actual things, so tangible things like people in the room, or they could be the cars that are parked outside, or the set of all the leaves on the tree. The objects, they can be real, tangible objects, or they could be abstract things like shapes. So so a set is a collection of objects. These objects could be anything, really. We call the objects in a set elements, or sometimes members of the set. And we usually denote the set with braces, sometimes called curly braces. You can write them like that, and then you just list every object inside of the set outright. So let's do an example of that. So here's one set. This is the set containing H2O, France, the letter G, it contains a penguin, if I can draw a penguin, something like that, looks like a penguin, and it contains, let's just do one more. And it contains the number 42. Okay, so that's a set. That set has, let's see, 1, 2, 3, 4, 5 elements inside of it. The elements are H2O, France, the letter G, this drawing of a penguin, and the number 42. There's no clear relation between any of those things, but what you can tell is these are just, it's just a list of objects. Probably another important thing to note is there is no order given on any set. So I could write these in any order, and it would be the same exact set. This is going to be the same thing as if I said France, a set of France, the drawing of the penguin, the H2O, the number 42, and then the letter G. These two are exactly the same set since they have the same elements inside, just written in a different order. So these two are the same. But there's no real interesting relationship between any of these elements. So let's take a different example where there is. Say the set 1, 2, 3, 4. So this is a nice set in that the elements are all numbers, right? It's all integers even, 1, 2, 3, 4. This set has 4 elements, and you can list them out nicely that way. We could also write this set as 3, 1, 2, 4. However, what we cannot do, and this is a convention that we use when we're talking in set theory, is we do not say this is the same thing as 3, 3, 2, 4, 1. So we don't. So just the same way that there's no order given on any set, we don't repeat elements. Of a set. Okay, so we only write each element once, so this is not good. So let's see, what's another example of a set that I can do? Alright, how about this? How about this set? The set with no elements inside of it. Well, it's a perfectly good set. It's just a collection, but it's a collection of nothing. So this is a very special set. This is called the null set, or the empty set. And we denote that by the symbol 0, or a circle. It's actually more of a circle with a diagonal slash that way. That's how we write the null set. And it's important to distinguish this between, from 0. So note, 0 is not the same thing as the null set. 0 is a number. So when we talk about 0, we say there's, say there 5 minus 5 is equal to 0. We can say that the temperature outside is 0 degrees. We can say the let's take a picture here. All right, so this is a picture. It's got, I don't know, 1, 2, 3, 4, 5, 6 stars in the picture. So there are 0 circles in the picture, right? There's only these stars. There are no circles. The null set is a set. So we were saying 0 is a number. The null set is a set. So it describes the set of circles in the picture is the null set. So there are 0 circles, and the set of circles is the null set. Alright, so that's one way of distinguishing between 0 and the null set. The next thing that I'm going to talk about are what are called subsets. So a subset, let me just define it in a more rigorous way. If A is a set, then a subset of A has every element inside of A. So what do I mean by that? Well, think back to when I was describing the real numbers. I drew this box, right? I said, here are the real numbers. I'm just going to do a little bit simpler of an example. So here's pi e square root 2. And let's just do the rational numbers. So just the reals and the rationals. Say 1/2 negative 7/8. So what we say is Q is a subset of R. The rationals are a subset of the reals. That was not supposed to be there. Since every rational number is also a real number. So that idea of containment that I was talking about before translates very directly to the notion of a subset. Okay? So a subset is really a smaller set, or possibly the same set. That's a trickier thing to get into, but for now all you need to do is think of it as a set contained inside of a larger set. Okay? So we can say that 1, 2 is a subset. So here's another example. This was the first example. Here's the second one. 1, 2 is a subset of 1, 2, 3. Okay? And as an interesting note, though I don't think you need to know this yet, the empty set is a subset of any set. Okay? So that's just a couple of interesting things. These are sort of ways we can talk about sets and have it mean something in terms of bigger sets, sets that contain other sets. Alright, so the last thing that I'm going to talk about is what's called set builder notation. And the motivation for this is that it's not always easy to write out all of the elements of a set. So it's sometimes hard to write out 1, 2, 3, 4, and so on. I can't just use these ... dots all the time. It's not always clear what I mean. So what do I mean when I say -3, 2, -1, 0? It's kind of unclear what I mean. So what I'm going to use is set builder notation to make it more precise, to specify the set more clearly. So we say, this is what it'll look like. So it'll look like the bracket x, and then a colon, or some people will use a vertical slash, but I like the colon. So bracket x, this is a lowercase x, colon, and then some property, some sentence that's that it has to be satisfied. So let's break that apart, because this is a new. This might be a new set of symbols for you. So here's what the brackets mean. The brackets mean the set of. Then what we have is that x right there. So that's the set of all x. Then the colon here means such that. So it's the set of all x such that, and then property P holds. Where property P is true. So property P doesn't always have to do it doesn't have to relate to x in any way. So let's look at a simple example. So let's say the set of all x such that x is even. Okay? Well, that set is going to be equal to, I'll use these dot dot dots, but what it means is the set of all even numbers. So it'll be, -4, -2, 0, 2, 4, 6, 8, and so on. So it's the set of all the even numbers. But I can write it this way. It's the set of all x such that x is even. I can similarly define another set. So the set of all x such that x is positive. So that's going to be the set, well, it'll be all the x such that x is bigger than 0. So there's going to be a lot of them. I don't think I could list them all out this nicely. But what I can say is that's going to be the same as if I say the set of all x such that x is bigger than 0, greater than 0. Right? Because if x is greater than 0, that means x is positive, since it'll fall to the right of 0, which is how we defined positive to be. So I can write the same set in many different ways, the similar way as I was able to write fractions multiple ways. Not 2/3, 2/4. I can write sets in different ways. And one thing that I should probably mention is there are a couple of interesting sets. So this was the set of all positive numbers. I can also specify the set of all non-positive numbers. So here's the set of all x such that x is not positive, which just means the set of all x. Sometimes my brackets get a little messy like that, so let me just try and clean that up. It's the set of all x such that x is going to be less than or equal to 0. So when x is not positive, when x is not bigger than 0, that means either x is equal to 0 or x is to the left of 0. So either x is less than or equal to 0. So that's how we define not positive. And we'll sometimes write that as non-positive. And we have similar definitions for negative, where x is less than 0, and non-negative, where x is greater than or equal to 0. And I think you should try and work those out and make sure you write them correctly on your own. It's a good exercise in understanding the way that you write set builder notation. So that'll be all for this video. I hope it helps you understand the notation for sets and to see that sets aren't really that complicated. All they are just collections of objects. So I hope this video helps. Thanks for watching, and I hope to see you again.